This video will walk you through the basic steps of setting up a heat exchanger example. Detailed step-by-step instructions can be found on the Virtual Labs Cloud Server desktop. After opening FLOEFD in Solid Edge, navigate to the upper left-hand corner and click Open. Open the heat exchanger assembly located in the B3 heat exchanger folder. FLOEFD is seamlessly integrated with Solid Edge, so users are already working within their familiar interface. This makes FLOEFD the perfect tool for engineers who want to test the impact of their design changes. The interior volume is simply closed by these lids. To start the FLOEFD wizard, click on Wizard. Here we will change the project name. This page allows you to change the unit system for this project. Please keep in mind that the unit system or single units can be changed at any time. FLOEFD does not require you to create a separate model of the fluid region. Simply pick an internal or external flow and FLOEFD will take care of the fluid region automatically. We will select the heat conduction in solids option because we want to analyze the heat transfer between the fluids through the model walls. FLOEFD has an integrated database containing properties of several liquids, gases and solids, and you can also create your own. We will add two fluids, water and air, and the default fluid type is liquids. As we have selected the heat conduction in solids option, we select the default solid material. Different materials to specific components can be created later as solid material conditions. For the outer wall, we define a heat transfer coefficient of 5 watts per square meter Kelvin. We set the initial pressure to 2 atmosphere. Please note that FLOEFD automatically converts the entered value into the selected unit system. We will now complete the project definitions by using the FLOEFD tree. Resize the computational domain by right-clicking on computational domain and selecting Edit Definition. The Xmax boundary is set to 0 and we select the symmetry condition. Since water is our default fluid, we need to specify the fluid region for the air. Right-click on Fluid Subdomain and click Insert Fluid Subdomain. Select the inner face of flange 1 and the subdomain is displayed in blue. And select Air in the fluid list. Next we will set up the boundary conditions. Right-click on Boundary Conditions and click Insert Boundary Condition. We click on the water inlet lid and set the inlet mass flow rate of 0.01 kilograms per second and hit OK. We'll define the other boundary conditions by following the same steps. For the water outlet environment pressure, for the air inlet, an inlet velocity 10 meters per second at 600 Kelvin, and for the air outlet environment pressure at 600 Kelvin. Our default material is stainless steel, but we don't want the lids to influence the heat transfer. Therefore, we right-click on Solid Materials, Insert Solid Material, and define the lids as insulator. In this model we are interested in the temperature of the tube. We therefore create a volume goal by right-clicking on Goals and selecting Insert Volume Goal. Select the tube part and select the average temperature solid box and hit OK. Click on the Run button to begin the solver. Click Run and the solver monitor box will pop up. The preview allows us to look at the results while the calculation is still running. The calculation is finished, we can create goal plots and export these to Excel. In the FLOEFD ribbon we select the cut plot, the right plane is selected, and in addition to the contour plot we select the vectors and define temperature in the parameter box. We can adjust the temperature bar by clicking, for example, on the maximum value. Click the geometry icon to hide the model. We hide this plot and click on the geometry icon again and click on the flow trajectories. Select the inlet water boundary condition change the color appearance to velocity, and adjust the maximum velocity to 0.004 meters per second. The parameter can be changed to temperature by clicking on the parameter name on the bar. In order to see the plots inside the solid model, we can also select the wireframe view. Click on surface parameters to show the calculated values, for example on the water outlet surface, and export these to Excel for further calculations. You can go through this example on your own and see more post-processing and results analysis. You will find a detailed tutorial including fully step-by-step instructions on the desktop of the cloud server. Thanks for watching.